Hi there, I'm Ha. This is just another video of me solving random number problem. So let's begin. So today we need to rotate a linked list um, by to the right, right, by k place. So if we are rotating, like the 5 gonna go to here, right? And then if we rotate another time, and the 4 gonna go to the front. Right? And they want us to return the head of the linked list, the new head of the linked list. So first of all, k. So let's say the length of the linked list is 5, right? If we rotate it by k time, which means we will go back to the original linked list, right? So before we even rotate, we always need to multiply by the length of the linked list, right? So that we can avoid uh, duplicates, right? We don't need to do unnecessary rotation. So how can we rotate? So we can use a circular linked list to rotate. So let's say this is our linked list, right? So the first time we iterate to the linked list, right, we can keep track of the length here. Right, when you get to here, our length gonna be 5, right? So we need to know the length of the linked list, and then we can set the current node, right? The last node dot next, right, equal to the head. Okay, so now we have a circular linked list. So our node is here, right? Our node is here. So uh, because we are at the end of the linked list, right? So now we need to find the new tail, right? Which is at 3. So if k equal to 2, right? Then the tail gonna be here, right? Like in the example here, k is equal to 2, right? The new tail gonna be at 3. So we just need to somehow uh get to the last node, right? The new last node, and then set the 3 dot next, right? Equal to null, right? And then we can return the new head, which is 4 here. Right. So how can we figure it out? The number of iteration we need to traverse. So let's say k is 2, right? Which mean if we are at the end, which mean we already traverse k times, right? Right. So we need to get to the end of the list by traversing another n minus k time, because like k minus k is gonna cancel out. We give us n, right? We give us like the length of the linked list. Right? If we traverse, we will rotate k times, which means k, right? K is already at the beginning of the list, right? So we can just traverse another n minus k time to get to the new end of the list, right? If k is 1, right? Then we need to traverse n minus k, which is 5 minus 1, which is like another 4 times, right? So 1, 2, 3, and 4, right? So this would be our new tail. Right? Because k is 1, right? And we are at the end of the list, right? Which means k, where we already traverse k time. So we need to travel another k minus 1, n minus k time to get to the new end of the list. Okay. So in the example here, k is equal to 3, right? So we just have to iterate 3 times. N minus k time, which is 5 minus 3 is 2 more times. Right. So n go to here, right? Oh, sorry, n is k is equal to 2, right? In the example. Yeah, so we need to traverse 3 times. K is 2 here. Okay, so it is 1 time, 2 times, and then 3 times, right? We get to 3. So before we set the new tail, right, we need to reset the head equal to this node right here, right? And then we set the node at next equal to null. Right, so now we're gonna have a new linked list after the rotation 4, 5, 1, 2, 3. Okay, So this is constant space in linear time, because the maximum we will rotate, sorry, the maximum we will iterate is like 2 times, right, through the linked list. So if we don't have a head, or if head is no, yeah, the number of nodes can be 0, right? So if we don't have a head, or if we don't have a head dot next, right? So if the linked list only have one node, and so that it doesn't matter how many times we rotate, you still gonna have the same uh the same linked list, right? So we can just return head in that case. Okay, so we're gonna count the length, the curve equal to head. So y curve, and then curve next, curve equal to curve next, and line for first. So let's console log the length here, and return the head at the end. You see if we get the correct length. 5, right? You have 5 nodes. Okay, so why are we checking for the next here? Right, because we want to set the circular link list, right? So the curve here gonna be at the end, right? The last node. We can set the product next equal to that, right? And we need to set our k as well. The k will be equal to k multiplied by the line, right? Because we don't want to do unnecessary rotation. Okay. So now we already set the circular link list, right? So what do we have to do now? So the next thing that we have to do is we need to so now the curve, right, is the last node. So we need to traverse another n minus k time, right? So let I equal to 0, I less than length minus k, I plus plus, and then curve equal to product next, right? So after we traverse another length, so n minus k time, so now we are already at the new tail, right? So we can set the product next equal to 0, right? But before we do that, we need to get the new head, right? We need to reset our new head equal to product next, okay? And we can return the head at the end, right? So this is by the new tail, right? And set the new, so by the new, so set the new head and tail, or five, and set the new head and tail, okay? It is uh, calculate calculate the line and set circular interest. Okay, so yeah, let's try this, and it worked. And thank you for watching.